Okay, good morning and welcome back to another session of data analytics course. In today's session, we will discuss the hypothesis testing. So let us first understand what is hypothesis. Well, hypothesis is an educated guess. It is an educated guess about something, and the hypothesis, it should be testable either by experiments or observation. For example, we can test whether some new medicine will work or not, or whether a new way of teaching is better than the previous one or not. All these are hypotheses, and they need to be tested against some using some method. So we have many methods to check the to test the hypothesis, like t-test, ANOVA. In the we'll see the working example of t-test in today's video. So if we talk about the hypothesis, we have two types of hypothesis. Null hypothesis and alternate hypothesis. So in the null hypothesis is represented by H naught, and alternate hypothesis is represented by HA or H1. So in null hypothesis, we always assume the equality. The common assumption is that there is no difference between samples. This is the default assumption. We can write it like this: sample A is equal to sample B. And what is the alternate hypothesis? All the other alternatives of null hypothesis comes under the category of alternate hypothesis. Like if we say sample A is equal to sample B, then alternate hypothesis may be sample A is not equal to sample B, or we can say sample A greater than sample B, or sample A less than sample B. So these may be the possible alternative hypothesis in this case. So basically, hypothesis testing the hypothesis can be tested using hypothesis testing, and further hypothesis testing can be divided into two subgroups. We have parametric test and non-parametric test. So if we talk about uh, what are the situations in which we should apply the parametric test or non-parametric test. So for parametric test, uh, there are certain conditions. First of all, for parametric test, the distribution should be normal. So parametric test is applied when the distribution, data distribution is normal. It is applied when there is some skewness, skewed distribution. We can apply parametric test for quantitative data, and this is applied for qualitative data. While using the parametric test, we normally use the metric scale. That means interval and ratio scale. And for non-parametric test, can be applied for nominal or ordinal scale. In parametric test, we normally compare the mean, while in non-parametric test we compare the median. So these are some of the important differences between parametric test and non-parametric test. Now if we further classify the parametric and non-parametric test, hypothesis testing, we have two types of hypothesis test: parametric test and non-parametric test. In the parametric test, the most common tests are t-test, ANOVA. We also have z-test, etc. In non-parametric test, we have Wilcoxon, ransom test, Kruskal, Wallis S-test. There are many tests available under both the hypothesis testing procedures, both parametric and non-parametric. But in this course, we'll particularly focus on t-test and the ANOVA. Both ANOVA is further of two types: one-way ANOVA and two-way ANOVA. We also call it one-factor ANOVA or two-factor ANOVA. So there is one more important term we should know when we deal with the parametric test. They are type 1 and type 2 errors. See, what we are trying to do, we have we have assumed some null hypothesis. We have taken some null hypothesis and we are testing it using some data, right? We have some null hypothesis and we are testing it. If we reject, the first condition is if we reject the null hypothesis, when it is true, the situation is referred as what? Type 1 error, right? Means we have some assumption, it was true, but we by mistake reject it. There may be a number of reasons for rejecting it. We might have taken some wrong data, some incorrect values to test for testing. That leads to rejection of null hypothesis, right? And the reverse, the opposite condition, the situation, if we accept the null hypothesis when it is false, it is known as type 2 error in statistics, right? So these two terms are also important. Now let us directly come to our parametric testing test procedures. So the first test we are going to discuss is t-test. Basically t-test is used to compare the means of two groups. If we have more than two groups, we will use ANOVA, right? So like I have already discussed, this t-test is a parametric test. So if somebody asks you what are the situations, I mean when can we apply the t-test procedures, so the conditions are same that we discussed with the parametric test. For all parametric tests, the distribution should be normal. The data should be normally distributed. Now okay, now we can use the t-test. We have normally three type of t-test. So the first situation is if the if both the groups come from a single population, then we perform a paired t-test. See, in this situation, for paired t-test, you will always see some before after relationship. For example, suppose a pharma company has invented a new medicine for hypertension, high BP. So what we are doing, we selected some 10 people, we recorded their blood pressures, then we give the new BP medicine to all the 10 people, and after 1 hour we again taken their blood pressure reading. So in this situation the people are same. We taken the data before given the medicine and then after given the medicine. So we will compare the means of both the groups. If the t test is, if the so our null hypothesis in that case would be that the average BP, the mean BP of the group is same before taking the medicine and after taking the medicine. So if our null hypothesis is accepted, that would mean that the new medicine has no effect on the blood pressure, right? So this is the first condition. The second condition is, if both the groups are independent. If the groups come from two different population, like the groups are independent. So this is also known as, this test is also known as independent t test. This test is also known as independent t test. And finally, if there is one group being compared against a standard value, perform a one sample t-test. See, it is clear from the name, one sample t-test. If we why do we use t-test? We use t-test to compare the means of two groups, but here in this case we have only one sample, so that means we have only one mean. So in this in such type of situation, we are always given some standard value which we want to compare with our sample mean, right? So these are the three main areas, these are the three main types of t-test, which we will discussing one by one in the next video. I will take one or two examples from each group. So thank you for now.